Hello, welcome to video number 75. This is about greatest common factors. We're going to kind of review everything we did in class about greatest common factors. Let's start by finding greatest common factors of numbers. So for this first problem, we want to find the greatest common factor of 18 and 30. One way to do this is make a factor table for both numbers, and that's why I've kind of started here. And we did this earlier in the year. So I start by writing all the factor pairs of a number. For instance, 18. Well, we can factor it as 1 times 18, so 1 and 18 are factors. We can do it 2 times 9, 3 times 6. 4 doesn't go into 18, neither does 5, and actually we can stop when we hit the square root of the number. The root of 18 is a little bit more than 4, so once we've tried up to 4, we know we're done. We found all the factors. 18 has 6 factors, 1, 2, 3, 6, 9, and 18. Let's do 30. 30 is 1 times 30. Okay, we could also do 2 times 15. 3 goes into 30, it's 3 times 10. 4 doesn't go into 30, but 5 does, and it's 5 times 6. Okay, we found all the factors of both numbers. So the greatest common factor is the largest factor they both had. Excuse me. So if I look at both tables, the largest one they both have is a 6. That's the greatest common factor. So if numbers aren't too big, this is not a bad way to quickly find their greatest common factor. Let's do these two, 24 and 60. So it's 1 times 24. 2 goes into it, 2 and 12. 3 goes into 24, 3 and 8. 4 does, 4 and 6. 5 doesn't, and we're kind of done. 60, 1 and 60. 2 and 30. 3 goes into it, 3 and 20. 4 goes into it, 4 and 15. 5 goes into 60, 5 and 12. 6 goes into 60, 6 and 10. And actually, we finished. Square root of 60 is 7 point something. 7 doesn't go into it, so we can know we're done. All right, again, look at the largest number they both have. This one has a 12. So does 60. That's the largest number they have in common. So the greatest common factor is 12. They have other common factors, but the greatest one is 12. All right, next way. Actually, this is a little bit more effective way when the numbers are a little bit larger. It always works, but if we have bigger numbers, we can use a factor tree. So let's make factor trees for these numbers. We're going to find their greatest or their prime factorization. So I take a look at 104. 4 goes into it. It's 4 times 26. You could also use 2 or some other numbers. 4 can be broken up as 2 times 2. And 26 as 2 times 13. So remember, once I get to prime numbers, I circle them. 104 is 4 times 26, but we can replace that with 2 times 2 times 2 times 13. So that's the factor tree for 104. Let's do 80 here. 80 is 8 times 10, which is 2 times 4. So 2 is prime, I'm going to circle it. 4 can be broken up into 2 times 2, and they're prime. All right, and 10 is 2 times 5. So we see that 104 is 2 to the third power times 13, and 80 is 2 to the fourth times 5. Okay, let's see what they have in common. What do they both have? They both have at least 3 factors of 2. So the greatest common factor is going to be 2 to the third. Then let's see what else they have in common. 80 has a 5, but 104 doesn't. 104 has a 13, but 80 doesn't. This is it. So the only thing they have in common are 3 factors of 2. So that would be 8. Okay, so factor table is a little bit simpler, but like I said, this works with larger numbers. All right, 48, let's break it up. 48 is 12 times 4. 12 is 4 times 3, so 3 is prime. And 4 is 2 times 2. I'm going to circle them. That 4 is 2 times 2. So we get 48 is 2 to the fourth times 3. All right, let's do 90. 90 is 9 times 10, which is 3 times 3. and 2 times 5. So we get 90 is equal to 2 times 3 squared times 5. Okay, let's see what they have in common. So the greatest common factor. Well, 48 has 4 factors of 2, 90 only has 1. So they have 1 in common. They both have at least 1 3, so it's 2 times 3, and that's all they have in common. So the greatest common factor is 2 times 3, which is 6. So we see what prime factors they have in common, and when we multiply those together, we get the greatest common factor. All right, now we're actually more interested in greatest common factors of expressions, but the number part is kind of the hardest part, I think. So here, on this first one, I kind of want to expand it out. This first expression is 4 times x squared times y cubed. So it's 4 times x, and then 3 factors of y. 6x cubed y is 6 times x times x times x times y. The variable part is actually the easiest part. So to find the greatest common factor, find the greatest common factors of the numbers. I picked small numbers, so this would be easy. 4 and 6, the greatest common factor is 2. Now, look at the variables. This has 2 x's. I can tell that from the exponent. This has 3. So I have 2 factors of x in common. All right, this has 3 factors of y. This has 1, so it's 2x squared y. All right, this one, 12 and 40. We can make factor tables or do a factor tree, but the greatest common factor of 12 and 40 is 4. Okay, so GCF is going to be 4. All right, this has 4 x's, this has 2, so they have 2 factors of x in common. This has 1 factor of y, this has 2 factors of y, so they have 1 in common. Greatest common factor is 4x squared y. All right, this takes us to our last kind of slide here. So the main point of what we're wanting to do is factor out the greatest common factor. So to factor an expression means to write it as a product, and sometimes this is the first step. We're going to write it as the greatest common factor times whatever's left. Okay, so here, first step, that's the hardest step, I think, finding the greatest common factor. Greatest common factor of 6 and 8 is 2. They both have at least 1 x, so the greatest common factor is 2x. And we want to put whatever we put in the parentheses here, 2x times that, has to equal our original expression. So 2x times what is 6x squared? Well, 2 times 3 gives us the 6. X times x gives us the x squared. This is minus, so I'm going to make this minus. I think 2x times what is 8x? Well, 2 times 4 gives me the 8. We don't need anything for the x. X times, you can think of this as 1, is x. All right, we got it. 2x times 3x minus 4 is equal to that. So we factored out the greatest common factor. We wrote it as the greatest common factor times whatever's left. Okay, so we'll go through these quickly. This one, the greatest common factor, 6 and 15. The largest number that goes into both is 3. This has 3 x's, this has 2, so it's 3x squared. All right, now we got to think 3x squared times what gives me this? Well, 3 times 2 is 6, so I need a 2 here. I have 2 x's, I need one more to make x cubed, so I need an x here. X squared times x is x cubed, plus 3 times what is 15? Well, 3 times 5. I have 2 x's already, I'll only need 2, so I don't need any more x's. There it is, factored. Once you get the hang of this, this comes very naturally. All right, like I said, hard part is the GCF. So 6, 12, 18. The GCF of those numbers is 6. 6 goes into all of those. Then, they all have at least one x, so we're going to factor out 6x. Okay, right? 6x times what gives me 6x cubed? I need an x squared. 6x times what gives me 12x squared? Well, I need a 2 to get the 12, and I need another x to get x squared. And then minus, because this is minus here. 6 times 3 is 18, so I need a 3. I already have one x and only want one x, so we're done with the x's. There we go, 6x times that. Last one, GCF is 5. 5 is the largest number that goes into 5, 10, and 20. They all have at least 2 factors of m. So it's 5m squared. All right. 5 times 1 would give me 5. So we don't need a number there. But we do need an m squared. So that m squared times m squared is m to the 4th. Minus 5 times 2 is 10. We have 2 m's. We need 3, so we need 1 more. Then 5 times 4 is 20. And m squared times 1 would be m squared. We don't need any more m's. Done. Okay, so this is our goal. The first step of factoring is factoring out the greatest common factor. Then we're going to see if we can factor the inside some more. So that's the topic of this week. All right, here we go. So I want you to apply what you know. Go ahead and find the greatest common factor of the following pairs of numbers. You can either use a table or a tree, whatever you want. Find the greatest common factor of these expressions, and then factor out the greatest common factor. All right, just like the last slide. Good luck.